Hello everyone, this is Bradley Sward, and this video today is the 2022 Advent of Code solution for part 1 of day 14 problem, otherwise known as Regolith Reservoir. So in this case today we're going to have sand falling down from a specific spot in a cave, and we're trying to see how much sand can fall before sand goes off down into the infinite pit of, we'll name it whatever we want to name it. So this is the example data. So it's tricky to kind of set up a grid, a list of lists here, so we can kind of set up numbers to set up positionings for the actual parts of the walls, or if you want to think of the actual cave that will hold the sand. So in this case that, and as they drop, they go down, and if they can't go down, they try to go down and left. And if they can't go down and down or down and left, they go down and right. And if they can't go either one of those three ways, they stop. And so basically at a certain point here, 20, how many? 24 times in, like this is basically what you get, where the sand will continue to fall out and fall into the infinite sadness there. And so the case is, with that said, for my larger data set with larger walls and all sorts of things, how much sand will drop before it goes off into the infinite of time. And so here is my code for the part 1 stuff here. So again, got it working. So what I did here was I broke this guy down into a series of, a list of lists. I got rid of this here as the delimiting character. So then that reduces down, and then I broke down each component into its x and y coordinates. And basically that's what this guy does right here, all of that. Double delimiters and things like that to get myself a grid of 2D positions in space. And then now I set up a grid. I was kind of surprised that I used 1,000 by 1,000 here, because 500, I wasn't sure how much space, I wasn't sure about our numbers here. So I'm going to say 1,000 by 1,000 grid, because we're going to start in the middle at 500, where the sand comes out, and it seemed to work out fine. So then now I need to fill in, basically, I figured there'd be a difference between the sand and the dirt and everything else, but it wasn't in this case. But this just goes through from point to point, figuring out, basically drawing a straight line and just hammering into that grid a bunch of ones. Or cave wall, cave wall, cave wall, cave wall, cave wall, cave wall, cave wall. Just like they have different letters for it, I just use numbers. And I just said zeros and ones. So if it's a 0, it's an open space. And if it's a 1, then it's a cave space. And that's what this code does here. And then now the finality of all of this here is basically, now that I have all that cave space, it's pretty straightforward at this point. Just try to keep falling down, and if I can, go down. If I can't go down, try to go down and left. If I can't go either of those two, try to go down and right. And if I can't go any of those three, then I put a piece of sand in, and I said, oh, okay, the sand landed, and I go on and I keep on going until I hit this position where no matter what happens, I basically am falling off the grid. And that's only going to happen if the thing falls all the way down to infinity, and then it will print out that the part 1 solution has however many different pieces of sand before it collided here. And I know that's really hard to read there, but let's see, I can make that just so you can see. That's 838 for my solution, and you can see here for this, my puzzle solution to part 1 here is 800. So my code works. So let me bring this back a notch or two here. Those of you who are trying to view my code, the few of you who are here at this point in the competition here. So pretty fun problem, actually relatively straightforward compared to some of these others that we've seen in the past. And here in a minute or so, I'll be doing my part 2 video. So if you want to see how to do that, click on that video if you haven't already. Take care, everybody. Thanks for watching.